In this video, we're going to talk about finding percentiles for normal distributions. Before we get started with this example in front of us, I want to remind us of the relationship between z-scores and values within our data set. So for instance, we know that z equals, or a z-score equals a data's value minus the mean divided by the standard deviation. Importantly for our example here, we're actually going to want to rewrite this relationship solved for our variable x. If you have some experience in algebra, you could easily verify this. All we're going to do is multiply by the standard deviation and then add the mean. But if you don't have a lot of background in algebra, it's not a huge deal. Here it is for you. If we solve this for x, we get x equals mu, our mean, plus z times our standard deviation. This is the relationship we're going to need to use in this example. And I just want to say, if you understand what a z-score represents, this should make a lot of sense. All we're doing is multiplying this z-score, which is in units of standard deviations away from the mean. And we know that if z is negative, it means our data value is less than the mean. If it's positive, it's greater than the mean. Anyways, if you have some algebraic background, this relationship should make a lot of sense, but it's not hugely important to the conversation we're going to have. Let's now move to the next thing we need to tackle this, which is actually a z-score table. Okay, so this is a z-score table. This is what we had to use anytime we wanted to relate a z-score with a probability or percentage prior to having technologies like TI calculators or Google Sheets to calculate these for us. We usually won't need to use these because it's much quicker usually to use a calculator to calculate these. But actually in the case of finding these percentiles, it's much faster to use a z-table. I just want to quickly describe to you how this z-table works. What you'll see down both sides on the left-hand side here on this vertical axis, these are values for z-scores, starting from negative 3.9 going to positive 3.9, which we know covers the vast majority of the values in a standard distribution. Importantly is to describe what's going on along the horizontal axis here. But to describe this, let's choose a specific place on this table. I'll choose this value right here. So how does this 0.87076 relate to a z-score? Well, what we do is we take the value here on the left of this row, so 1.1, and then we also add this hundredth value. So what we're getting on the left is the detail to the tenths place, but then we get a little bit more detail with this horizontal column right here. So what that right there is representing is that a z-score of 1.13, this 3 is coming from that horizontal or hundredths position right here, that relates to a probability or a percentage to the left of this value of 87076, or about 87%. All right, so then you might have an idea of the process we're going to use already. But for instance, in this first example, what we're being told is that the distribution of passenger vehicle speeds traveling on I-5 in Washington is nearly normal. So it's a normally distributed data set with a mean of 72.6 and a standard deviation of 4.78. So I'm just going to write these out here so I don't forget them. I have a mu value of 72.6. That's the mean or the average. And we have a standard deviation of 4.78 miles per hour. Okay, so if we're being asked about the 70th percentile, what we're going to do now is go back to that z-score table, and we're going to find the z value associated with the 70th percentile, and then we're going to use this formula right here to find the x value. So let's go look at that z table right now. So here we have our z table, and I'm looking for the 70th percentile, and I found it right about here. Okay, so this value, one could actually argue, I want to say, is that you could round this up to the 70th percentile. Generally speaking, it won't be a big deal which one of these you choose. You should get an accurate enough answer, but I'm going to choose this position right here. So this at 0.701, this has a z-score of 0.53. So what I'm going to do now is take a z-score, and I'll write this right here real fast. It's z equals 0.53. This is what's related to the 70th percentile. I'm now going to go back to my formula and figure out what speed that relates to. So we again found our z-score that relates to the 70th percentile. All we have to do is use that relationship above to find the x, the data point in this case, or which is miles per hour for the 70th percentile. And the work is simply by calculating x equals mu. Mu in our case is 72.6, and adding our z-score of 0.53 times our standard deviation of 4.78. When I throw that into my calculator, what I get is 75.13 miles per hour. Okay, so again, that process is we're going to use the z-table to find where the 70th percentile is, find the z-score, and then throw it through this formula right up here. All right, in the second example here, we're being asked how fast do the fastest 5% of drivers travel? The only real difference between this and the first question is we're not being told about a percentile, but we can use a little bit of intuition to know that the fastest 5% would be the 95th percentile. And against the 95th percentile, because the 95th percentile represents the data value that's bigger than 95% of the data values. So all we need to do now is go back to our z-table. We are looking for that 95th percentile, and if we zoom in right here, it occurs right about, let's see, 94.59, right here, 95. This is the 95th percentile, and that's related to a z-score of 1.65. So what we need to do now is the same work we just did, but with a z-score of 1.65. And we throw it through that same formula. We have x equals mu, which is 72.6, plus our z-score of 1.65 times our standard deviation of 4.78. And when I do that calculation, I got 80.49 miles per hour. Again, just big picture, the conversation that we're having is we find percentiles by finding the associated place on the z-score table that relates to that percentile, finding the z-score, and then taking that z-score and throwing it back through the z-score formula, but the one associate or solved for our x value. They look like these beautiful things. They can be kind of confusing to look at, but let me just kind of talk through this real fast, especially kind of given what the side of this side of the table represents and this table. Basically, these both represent the z-score. On this vertical column right here, these are telling you up to the 10th place of the z-score, and then these numbers right here are telling you the 100th place of the z-score. So let's pick one of these. It doesn't really matter too much. I'm gonna go down here by the bottom, and let's take this. This is about 48%. So it's the 48th percentile of our data.